All right, in this section, we're going to go ahead and talk about introduction to radicals. We're going to talk about basically computing radicals as well as what happens when negatives are involved. So some quick vocabulary. When we talk about radicals, we have two main components to this. The first one is called the radicand. This is the number or expression that is inside the root. So for instance, on this one, 32, our official name for it is the radicand. The second thing we have is the index. The index is the type of root indicated by the small number in the upper left corner of the root. For instance, this here is a fifth root. Now, radicals are the exact opposite of exponents. So for instance, squares and square roots are considered opposites. Cubes and cube roots are considered opposites. Fourth powers and fourth roots are considered opposites. So as we look at the next couple of examples, try to keep that in mind. So please use your calculator when evaluating these. We want to first talk about square roots. When we talk about square roots, keep in mind we are trying to figure out what number squared equals the inside number. So for instance, if we compute the square root of 49, we want to know what squared equals 49. And we should get 7. 7 squared equals 49. And so the square root of 49 is equal to 7. If we look at example B, we have the square root of 225. So I want to know what squared equals 225. Your answer should be 15. All right, let's go ahead and look at some negatives. So notice that these two problems look very similar, but there is a huge difference between what we're going to get as an answer. If we look at C, this is minus the square root of 16. The square root of 16 is 4 minus the square root of 16, or negative square root of 16, is negative 4. If we look at D, when you type this into your calculator, if you're using if you have one of the calculators that like your cell phone, make sure that you have negative 16 and then hit your square root button. Make sure also, if you are using a other calculator, make sure that you have parentheses around the negative 16. If you type this incorrectly, you should get an error message. And what this results in is not a real number. And so let's talk about that. We are trying to figure out a number squared that is equal to negative 16. But the problem is if you square any number, your answer is going to be positive. You are never going to end up with a negative answer when we talk about real numbers. The result of this is actually referred to as an imaginary number, which we are not going to discuss in this class. You will probably see it in either 121 or possibly 190. For our intents and purposes, as I said, we are dealing with the real number system, and so we are going to say not a real number. Please note, this is different than undefined. Undefined is only pertaining to division by 0. Okay. Similarly, we do not say no solution because we are not trying to calculate a solution. We are just trying to find the number. So for us, this is going to be referred to as not a real number. All right, let's keep going. Let's look at cube roots now. All right, so let's start with cube root of 8. I want to know what cubed equals 8. Our answer should be 2. For B, we get cube root of 64. If you put this in your calculator, remember we're looking for what cubed equals 64. We should get an answer of 4. 4 cubed equals 64, so the cube root of 64 is equal to 4. All right, let's look at some negatives. Just like on the previous problems, if we have the negative outside the cube root, we are going to keep it. And then the cube root of 125 is 5. So negative cube root of 125 is negative 5. Now what happens if it's on the inside? So here's the thing. If you type this in your calculator, make sure that you do have the negative in the right place. We should get negative 5. Remember that when you cube a negative, you're having an odd number of negatives, and so your answer stays negative. Similarly with cube roots, you will keep the sign of whatever number is inside. So note, you are allowed to take the cube root of a negative number. And the cube root of a negative number is going to be a negative number. All right, so that takes care of cube roots. Let's go ahead and look at fourth roots. So the first one that we have is we have the fourth root of 16. The fourth root of 16, 2 to the fourth equals 16. And so the fourth root of 16 is going to equal 2. All right, what about the fourth root of 1 over 81? We'll talk about this in a little bit more detail later, but what we're going to do is we're going to split up our root to the top and the bottom. So if we calculate this now, the fourth root of 1 is just 1. And the fourth root of 81 is 3. So the fourth root of 1 over 81 is equal to 1 over 3. Okay, let's bring in our negatives. If we look at negative fourth root of 81, same thing again. I'm going to keep my negative sign, and then I'm going to calculate the fourth root of 81. The fourth root of 81 is equal to 3. So minus fourth root of 81 is equal to negative 3. All right, what about fourth root of negative 81? Because we have an even index, this is not a real solution. If you raise a number to the fourth power, because it is even, your answer is always going to be positive. It's never going to be negative. And so there is nothing that I can raise to the fourth power to give me negative 81. Therefore, you cannot compute the fourth root of negative 81 in the real number system. There are fourth roots. All right, fifth roots. Using a calculator, if we try to take the fifth root of 32, 2 to the fifth equals 32. So the fifth root of 32 is equal to 2. What about the fifth root of 243? This one you may need a calculator. Most of you probably don't know that 3 to the fifth equals 243, and therefore the fifth root of 243 equals 3. All right, let's bring in our negatives. The negative fifth root of 32 is going to equal minus 2. And just like we saw with cube roots, the fifth root of negative 32 is negative 2. Negative 2 raised to the fifth power is negative 32. And so we get the fifth root of negative 32 is negative 2. So note that we are allowed to take the fifth root of a negative number. And the basic rule is that you are allowed to take any odd root of a negative number. So let's go ahead and kind of summarize what we have. Even roots, we're going to go ahead and split this into two different categories. Even roots, the inside number must be a positive number. If the inside number is negative, the answer is not a real number. Please note that not a real number is different than no solution. We are not solving right now, we are just computing. And so we want to keep in mind that we are not going to use phrases like no solution or undefined. This is not a real number. All right, odd roots. The inside can be positive or negative. You can calculate the odd root of any number. So odd roots, we're good. We can always do a computation. We're going to revisit this concept when we talk about domain of radical functions a few sections down the road. All right, let's extend the concept and bring in some variables. So one thing to note is when we talk about roots and exponents, if our index and our exponent are the same, then they will cancel. So the seventh root of x to the seventh, I can cancel my root and my exponent, and we're just going to write what is left over. So this is equal to x. B may look rather challenging at first, but we're going to do the exact same thing. I'm going to cancel my root and my exponent and write what is left over. We are left with t minus 1. All right, those are some basic ones. Let's bring in some numbers now. So C, we have the square root of 16x squared. If I take the square root of 16, I get 4. Now, we do not write it in, but technically, when we talk about square root, this is a second root. And so again, my square and my square root cancel, leaving me with just x. So the square root of 16x squared equals 4x. All right, D, we have the cube root of 27. If I do the cube root of 27, I get 3. For my variable, my cube and my cube root cancel, and we are left with x. Last one, the fourth root of 625 x to the fourth. If you compute the fourth root of 625 on your calculator, you should get 5. My fourth root and my fourth power cancel, leaving me with just x. So there are some basic problems involving variables. We will revisit this more when we talk about simplifying radicals that are not perfect powers in the next section.